Next question is question number 59 of this series IIT JAM 2026 Mathematical Statistics PYQ Solution. So the question is as we have the observed value of random sample of size 9 from the distribution having continuous and strictly increasing cumulative distribution function as this. And m here is unknown and median of the distribution. And we are required to test that under h0 m is equal to 0 against h1 m is greater than 0. And here we'll use sign test, and if h0 is accepted at level 0.05, eta will be 1, else 0. We need to find the value, p value of the test as p and eta, that is p plus eta. So this topic, the question is from the topic of non-parametric. So by using sign test, here we'll have to count the number of positive sign and number of negative sign. So positive sign will be, that is this 1, 2, 3, 4, 5, that is 5, and the negative sign will be 1, 2, 3 and 4. Under h0 we can see m is equal to 0, that imply half of the observation are greater than 0 and half of them are less than 0. That means the positive and negative sign are equally likely. Or under h0 we can say that the number of positive sign, that is x represent the number of positive sign, is distributed as binomial, and we have the 1 2 3 4 5 6 7 8 9 comma probability is half. Since probability is half, that is positive sign and negative sign are equally likely, that imply it is symmetric. So now in order to test under h0 that m is equal to 0 against m is greater than 0, we have to find the probability of x, that is the number of positive sign, is greater than or equal to 5, that is the p value. Means x is greater than or equal to its observed value, that is 5. Since we know that x is number of positive sign is 5 and x, and here the distribution is symmetric, the probability will be 0.5. And we can see the p value is, since alpha is 0.05, we have to check for the level of 0.05. Since p value is greater than alpha, that imply we do not reject h0. In that case eta will be 1. So that imply eta will be 1, and we need the value of p plus eta, where p is the p value as 0.5 plus 1, that is 1.50 is the answer. That is 1.50 is the answer.